Hi folks, today in this particular video we will be going to discuss about what is a big O and big O notation and various types of big O notation. Basically we will understand. Basically before going to the big O notation, I will be giving you short recap, right? Like why this big O notation is required. We will be taking particular use case. Then we will try to understand this big O notation with in greater details about it. Like wherever you take any algorithms, there are three types of cases, right? Best case, worst case, or average case, right? What do we mean by this? Best case, worst case, and average case. See, if it is the best case, the algorithm is performing good. Worst case, it is lagging between, it is like a not negligible, right? The algorithm is not performing that much what we wanted. If you consider as average case, if it is a best case and worst case, if it is in between of that, okay, so we will be telling it as an average case. Let's consider with this analogy, right? Let's suppose you consider one car, okay. Let's take you went to showroom, you took the test drive, you took one particular vehicle, it performed very well, its efficiency was very good, right? How you will be telling that the engine is very efficient, engine is very weak, or engineering is very worst, right? Consider it like this, okay. So this three things is in terms of an algorithm. Now let's understand, like let's suppose you wanted to send the file to another member, right? Let's suppose the file is 1 KB, right? If you are sending the file through mail, you can directly share to that person very easily, right? When the particular size of a file increases, right, how will you do this? Nowadays there is internet, data is very low, right? Cost of the data is very low, so you can transfer it, you can anyhow you can share it to the Google Drive so that we can give them access, right? And uploading the file also increases. If you like, it depends upon how much GB of data that you are transferring, basically, right? It depends upon the efficiency, how much efficient your data package is about and all, okay. All right, so understand with this analogy in very great thing. Let's suppose you are going to purchase any bike or a vehicle, anything that might be considered, right? So for that particular purpose, you will be categorizing into three things, right? So now the question is, what is a big O right now, right? For any particular language, programming language, it is a language. Big O is the language and the metric. You will be trying to describe how much efficient of the algorithm is about. Okay, understand, big O notation is nothing but big O is a language or a metric that you will be describing how much the algorithm is efficient. What is a big O? Big O is a language. It will shows the metric. Understand one thing, it shows the metrics. And second thing, understand, it is a how much efficient the algorithm is about. Two things it will talk about, how much efficient the algorithm, okay. In the previous video we discussed about how many types of an algorithm is about. Now we are discussing about what is a big O, right? Now we understood what is a big O, right? Big O is nothing but it is a language which will shows the metrics. And second thing, number two, and it will talk about how much efficient the algorithm is about, okay. how much efficient the algorithm is about. Alright, this is the two things you have to consider it. Alright, so this is the two things you have to consider. Understand the what is a big O. Right, so now big O notation, it is categorized into the three types. Right, as I told you, big O categorized into three types. Okay, number 1, number 2 and number 3. Right, there are three types. Understand, like best case, best, average and worst case. Okay, so there are three types of a big O notation: best, average and worst. Right, worst case. Worst case, these are the three types. So whenever we are telling as a best case, it is an omega, ohm. You understand, like you understood the physics, right? Like Ohm's law, right? It is a convention of like that. Okay, ohm, like ohm actually. Like how can I represent it? I will just show you one whiteboard animation so that it will be fine actually, right? So it will be better to explain. Okay. Just give me a second, folks. So I will explain you what's a whiteboard, how we will representing that, so you will understand like this. Okay, best case is represented by this convention. Okay, sorry for that, folks. Best case, this is a convention we will be writing, omega, right? Omega, this convention we will be called as omega. Now theta, whatever the theta value it is, okay, we will be telling it as average case. Okay, average case. And big O, we will be telling it as worst case. Okay, worst case, we will be calling this convention as worst case. Understand, O, which whatever the big O will be there, it's a worst case scenario, what will happen. Okay, understood? So these are the three things you have to understand, like convention: best, average and worst. What is the best? Best is an omega, average is a theta, and worst case is a big O. Understand like that. Okay, these three things we understood. Okay, so I forgot to like this is a thing, right? And big omega, these are the things. Now what this best case, average case and worst case will represent. Now we have to understand that whatever the big O notation is about, right, that we have understood, it is a worst case, right? It is a first case, first of all. But what's the significance of that? Now it is a complexity, right? Time complexity that you are measuring, right? That is going to be less than or equal to worst case. Okay, worst case is nothing but what? It is equal to worst case, right? It can be less than or the, like whether that particular algorithm can perform well, or it can come into the category of worst, right? Understand like this. Big omega, big O, it is a type of a complexity. Okay, it will be coming into this condition. Understand the things here, folks. It is little bit condition that you have to understand. One thing is you have to understand about it. Okay, I will show you that worst case is less than or equal to worst case. That is a big O, right? What is categorization? I am telling you. Okay, big omega is a best case, right? Best case is at least more than, the best case. Okay, that is going to be at least more than. It is a complexity that is going to be at least more than the best case. So that is nothing but a big omega. Now when you consider about big theta, it is an average case where it will lies within the bounds of worst and best, right? See, understand like this. I will plot one graph that so that you will understand. See, this is a worst case, right? This is a best case. Now average case, how it will perform? It will lies the outbound between this best case and worst case, right? Worst case and best case, then it will lies here, right? So how you will be considering it as? If it is a worst case, what you will be representing? Big O, right? If it is a best case, what you will be telling that? Theta. It is an average case. Theta is here and this is an omega. Sorry, it is an omega, folks. Okay, convention here to understand. Theta is nothing but average case, big O is worst case, right? It is lying between the two. Understand like this. The algorithm which is performing well, it is a best case if it is performing like medium kind of a efficient. It is not lies between the like it is between the best and worst case. Okay, so that is nothing but average case, which we will be calling it as theta. So now understand, now what is this big O? In the big O convention we will try to understand that. Now big O, in the big O you understood that big O is a worst case scenario, right? So understand like this, for each amount of operation it will be taking, for each task it will be taking same amount of operation. Okay, understand like this. Let's say I am taking a calculator, right? If I am performing 1 plus 2, it will be going to take the same amount of time, right? Let's say if I am taking 3 plus 1 also, it is also taking a same amount of operations. Are you understanding? Are you agreeing with this, right? So that is particular thing we'll be calling it as constant complexity, constant time, same amount of time it is taking to execute particular operation, right? For that particular sense, we will be telling that big O of 1. Understood? So big O of 1. Okay, so big O of 1 is nothing but it is taking the constant amount of time to execute that particular operation. That may be anything, whether you are adding two numbers or adding anything, any particular operation that you are performing. If we plot a graph about this, okay, so how it will be taking, let's suppose it is a 0 and this is a 1, right? So same amount of operation, same amount of time it is taking. So what we can say, it is taking constant time of complexity, constant time, one unit of time it is taking to execute particular operation, right? Constant. So this is the thing you have to understand, element and the operation. Understood? So this is the thing you have to understand, right? You got the clarity about it, like how the things will be going to take place here. So there is a time complexity. So I will be plotting some graphs, folks, so you will understand the things, how the things is about it, right? So now if I tell it is taking the linear time complexity, so in what case it will be taking? If you are looping, let's suppose looping constructs if you are using, right? In such case, big O of n time complexity it will be going to take, like n number of operation is performing, right? So for that particular sense we will be executing that, right? So like this the things will be going to work out. So algorithm, if you are finding an element in a sorted array, like let's suppose if you are, there are list of numbers, right? List of numbers, there are list of numbers, you are finding particular element, right? So it takes the logarithm, big O of log n, worst type complexity of log n. So n times of operation is performing, you are performing the things. If you are performing the nested loops, loop inside the another loop, then big O of n square, right? If you are performing the recursion kind of a inside that, it will be taking big O of 2 to the power of n time complexity it will be going to take. It is different categories, folks. Like if you are performing simple you are adding the numbers, then you are taking it as big O of 1, right? If you are looping through the numbers from 1 to n, it will be taking big O of 1, big O of n times, right? So it depends, like time complexity will be dependent upon the number of input you are giving, and it depends upon size of input data, right? So it depends. So understand the complexities, that whenever it comes a big O of 1, it will be taking same amount of operation to execute the program, right? So this is a thing you have to understand. There are two, we will be not talking about best, like if you take any algorithms, right, there will be worst case part about it, and you cannot say that it is, your algorithm is very efficient, right? This is the things you have to consider it about it. Okay, so this is a part about the things now. Okay, so let's understand of big O of n complexity with respect to one particular examples, right? So that you will understand how we will be working upon it, and you will understand the things here. Okay, now let's take an VS Code. So we'll start with the programs part, so that will be the best to understand the time complexity. Okay, so we'll just close this project, close this window. Okay, VS Code, close this folder, close folder. Yeah, where is that? Open folder, create another folder, _DSA. Okay, so we'll just open here and we will write the programs here now. So print dot ht, not py. Okay, so we'll take one function. Okay, print items. So understand, we are printing the items and we are taking the input as a n here, right? What I told you here, we are taking the number of inputs, right? Whenever comes the n inputs, so it is a big O of n complexity, right? So when we are iterating anything for I in range of n, right? So what we are doing here, print I. Let's say if I am calling, see this function actually, print items of 10, so how many number of operation it will take? 10 iteration it will be going to take to execute that particular program, right? It depends on the number of inputs. This type of complexity depends upon the number of inputs, right? How many number of inputs you have given here? 10. So 0 to 9 is how much? 10. 10 number of operation is happening, right? So what we can say that in what it justifies now, big O is a worst case of complexity of how many number of inputs, and here n is 10. Okay, so this is a particular thing you understood, like whenever there is a looping the numbers through 1 to n, how many, no matter what, how many number of operation is there, the complexity of that, it will increases based number of inputs, based upon the number of inputs. How many number of inputs you increase, that much number of time it will be going to take. So that's why we will be generalize this particular kind of a problem, big O of n. Alright, so now next things comes into the picture, that is a nested loops, right? I have already told you, when there is a nested loops, we'll be telling it as big O of n square, right? So now what we'll be going to take it here is, we will be commenting out this thing. Now we will take another problem statement right now, so you will understand in greater details. Now I will be taking this problem statement, but we'll be going to do in different way. Alright, so you will get understanding how the things, why it is like this. We are removing the constants from the analysis, asymptotic analysis, that is whatever the categorization of the big O basically. Alright, so we'll take it forward. Okay, for I in range of n, print I. Then we'll tell that for j in range of n, it is what? Print j, right? See how it took first, what it took, 0 to 9, 0 to 9, right? How many number of operation it is taking, right? So let's say this I operation is considering it as 10, right? 10 number of operation. First is doing this number of operation, printing, then once again it is getting here, and so now n is greater than anything, so it is equal to that, right? Equal to n. So what will be telling that this is the n time complexity, big O of n, right? So for this particular purpose, why, first I will explain you why we are dropping the constants here first, right? So it is possible that for every input, right, input n, it is taking the big O of n1 code for specific input, right? Constant amount of time it is taking for particular input. Let's suppose you are represented as a 10, so how much time it will take? 10 means 10, 20 number of operations it is doing that, right? So now, so big O just describes, so now big O notation, what it will be going to describe, like different computer will be having the different architecture, right? And it has having a different constant factor. Okay, so let's say we have algorithm, we have, right? Different algorithm have some basic idea. It has own internal complexity, computational complexity basically, right? So there are some problems. In some machine it can take X amount of operations to perform that, execute that algorithm. In that, let's suppose there is a big O of 2n, 2n amount of operation is taking. So what we'll be going to take, which particular algorithm having a maximum, so we will be taking that amount of operation first. Let's understand with this big O of n square first, right? So nested loops, as I explained you, right? Here let's say if I remove this, okay, this was a big O of n only, right? So we'll just remove this. Okay, we'll write for I for j in range of n, right? For I in range of n, for j in range of n. So what we are doing, we are printing both the elements. So what we are doing, print I comma j. Okay, so we'll just execute this, right? We will execute here. Okay, okay, so if we execute this, so we'll just take it as print items of 10. See, you just 0 0 0 1 0 2 0 3 0 4. So how much it is taking? 0 into 0 0, 0 into 1 0, 0 2 0 0 0 0 0 0, everything 0, right? So now when it comes to 1 into 0 0, 1 into 1 1, 1 into 2 2, okay? So what is happening, if you observe it, n into n means nothing but n square, right? This for loop, it's taking as big O of n complexity time complexity, and this loop is also taking n time complexity. So if you consider n into n is nothing but what, n square, right? Understanding, right? So this is a thing you have to understand whenever there is a categorization, folks. I will repeat once again. Okay, I will repeat it once again. I repeat it once again. When there is whenever you are adding two numbers, it will be having a constant factor. Okay, so that it is a complexity of big O of 1. If you are looping through the 1 to n numbers, there will be n time complexity. if you are finding the element in a sorted array, it will be log n complexity. Okay, if you are nesting up the loops, then it will be n square. Let's say if you are performing the recursion kind of a problem, it is an exponential, it will be 2 to the power of n. Alright, so this is a kind of a based upon the problems you will be understanding when you will be working on the real world problems, folks. This is just a generalization that I am giving you bigger picture about it. Whenever you consider any kind of a problem statement, you will understand that if there is a for loop, it will be having an n time complexity. Inside the another for loop, it will be taking another n time complexity. If you multiply it, n, right, n into n, there will be n square, right? Okay, you understood the clear idea, I guess, right? So another concept come into the play is drop the non-dominant terms. Non-dominant terms, basically, let's suppose who has a higher power, you will be considering those terms first of all, right? So this is a thing you have to understand. So in the print items, right, I took this is a for loop, print I comma j. Now if I consider another for loop here, right, for k in range, if I'm adding some constant factor here, see, if I'm adding this, see, if I'm printing k value here, so will you take this will be, as we know, big O and big O and big O n square. And what is this particular thing? Big O of n, right? So big O of n square is greater than big O of n, is it? Right. So the term of n square is greater than big O of n, right? So we will be consider it as a big O of n square. So what will be going to take, which is having a higher value, higher term value, we will be taking those complexity and we will be calculating that, and we will be considering it as that value, right? If you just execute it, right, see, we will be considering those operations first here, 0 to 9. Okay, so this is a particular thing you have to try to understand, like 0 square is 0, 1 square is 1, 2 square is 4, right? So it will going to consider it. So we will be going to drop the non-dominant terms, basically. See, there is a different kind of a problem I will explain you. Like there are a sorting kind of a problem you are solving, basically, right? If you are solving the sorting problems, there is one approach called as a divide and conquer, right? Here, let's say you are finding a number 1. Okay, so what you will do, let's say there is 1, 2, 3, 4, 5 and 6. So what you will do is you will divide this into 4 terms. So divide and conquer, right? We are dividing and finding that element, basically. So what happens basically here, just a minute, I will just show you. So now we'll divide this particular thing into 2 components. Now 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 8 5 6 7 8, right? 5 6 7 8. Okay, so once again we will be dividing these things. Understand, like this. 4 is there, we'll divide into 2. Okay, 1 and 2 and 3 and 4, right? We'll be dividing like this once again. 1 2 3 4, right? So we'll be going to divide this 4 5 6 7 8, and we'll be further dividing those elements. Why? Because 1 is here, we'll neglect this, we'll be not trying to do this, right? So we divide it, but here 1 is not there, so we'll neglect it and we'll further divide it into 2 parts here. This tree we will be going to traverse it. 1 2 3 4, right? 3 4. Now if you understand logarithmic about it, right? Log n, 2 to the power of n is nothing but, how you can represent it, log n, let's say 2 to the power of 3 is there, right? So what will be going to tell? It is an 8, right? 2 to the power of 3 is 8 value, result is 8. So in the logarithmic, how you can write as log 8 to the base 3, log 8 to the base 3, which is base 2, which is equal to 3. Okay, 2 to the power of n is 8, right? 2 to the power of log 8 to the base 2, which is equal to 2 to the, which is equal to 3, right? So this is a thing you understood now, right? So how many number of operation it will take, you understood here. Basically, if we are performing same kind of an operation, it will be going to take big O of 1, right? In what case log n it will be going to take? Whenever there is a problem, if we are adding a constant term, right? Constant factor also if we are adding, we are dropping the non-dominant terms, right? So in that case we'll be considering who has a square value, number of power which has increasing number of, and we'll be considering those powers first, and we'll be neglecting the less power, right? So big O of n square is greater than big O of n, so we will be considering it as which is having a higher number of power, right? So those conditions will be considering it as a big O log n. So understanding simple words, 2 to the power of n, let's suppose 2 to the power of 3 is equal to 8, it is a result, right? Result. So now result will come in value, right? Log 8 to the base 2, which is equal to 3. What is the power value? We will be considering it here. Here we'll be just writing the log value. Understand like this. So I understood this part is very difficult, folks. So to once again go through this video so that you will understand it in greater details. I understand this topic is very much hard and in the first go, so try to revise it. I hope until this video you understand this concept. I break it down with the particular concept called as how the shopkeeper is here. You will be going to do the test drive and how you will be identifying this particular case. So I hope you understood this particular video. Okay, I am thinking that everyone subscribe to my channel. Basically I am seeing in my analytics in the video, so many people are watching this video but never subscribe to the channel. if you don't subscribe, it's not a loss for me. You will be not getting the more content, valuable content for you. Basically, you will be not getting notified if you not watch this particular video, right? So it's your benefit, folks. I am creating the quality content, but you are not never subscribed to my channel, so it makes an impact for you, and it will be very you will it motivates me basically to put the more content into my channel basically. Thanks a lot, folks. I hope you enjoyed this particular video, and I'm thinking that you will be subscribing to my channel. So that is my goal, folks. My goal is basically to create a content. I'm hoping that everyone will reach out to me to make my goal to be 1000 subscribers basically. Okay, that's it about this video, folks. I have to convey this idea to you folks, so that's why my objective was there. Thanks a lot.